Mutations. You have two learning targets in this module. I can identify and describe three types of mutations, and I can determine how a mutation will affect a protein. You have recently learned how to make a protein using the information coded in your DNA. You will recall that a protein is nothing more than a chain of these molecules that we call amino acids held together by peptide bonds. Proteins are some of the most important molecules in your body. They're like tiny molecular machines that do the jobs that keep you alive. I need you to understand that a protein's function, or its ability to do its job, is all about its shape. So up in the top left-hand corner here, you see a protein and you see its shape. You'll note that the shape of that protein is the way it is because of the sequence of amino acids that were used to create that protein. Now I want to give you an example of a protein and how its function is all about its shape. So here's a little protein. It's the enzyme lactase. Lactase is an enzyme that lives in your stomach, and it basically swims around in your stomach acid, and it looks for these little tiny sugar molecules called lactose. Lactose, as I'm sure you know, is the sugar found in milk. Now, what you'll notice about the shape of lactase is that it's perfectly fit right here at its active site to take this lactose in and break it down. So that's lactase's job. I'm sure you've heard of people who are lactose intolerant. People who are lactose intolerant can no longer make lactase, or their lactase enzyme is misshapen so that the lactose will not fit into the active site of lactase. So again, a protein's function is all about its shape. So what is a mutation? A mutation is simply a change in the base sequence of a gene. Now, a lot of people think when they hear the word mutation, oh my gosh, mutations are terrible things, right? They deform us and they really make it hard for us to survive. Well, I need you to know that it is actually thought that most of the mutations that occur are actually neutral. In fact, I'm willing to bet that each and every one of you in some of your cells have accrued mutations. Neutral mutations have absolutely no effect on an organism's ability to survive and reproduce. Now, of course, some mutations are bad, or, if you will, deleterious. A deleterious mutation is a mutation that decreases your ability to survive and reproduce. It makes it more difficult for you. One of the important things that I want to point out, and this will be really important later on in our next standard, is although it's very rare, sometimes a mutation can be beneficial. That is, improving an organism's ability to survive and reproduce. So to recall, a mutation is a change in the gene sequence. This can cause a change in your mRNA, and sometimes this can lead to a change in your protein structure. Now, you will recall that if you change the structure of a protein, you might alter its ability to do its job. So back to our learning targets, I can identify three types of mutations. The first type of mutation I want you to recognize is a substitution mutation. And a substitution is when a single base is swapped with another. It's a lot like in a soccer game when a coach substitutes a player. He takes one player out and puts another player in. So I want to give you an example of the substitution mutation. Down here, I have a gene. There's the start of the gene, and here's the end of the gene. Normally, when your body copies the DNA, it does so with exquisite fidelity. However, sometimes the machines that are responsible for copying your DNA can make a mistake. So, for example, a T might be substituted for a C. So here's the mutation right there. And again, that's called a substitution. In this case, the base T has been substituted by the base C. That's a substitution. Now, a substitution can have one of several effects. First of all, that substitution might be a silent mutation. This is one possible outcome. A silent mutation is a mutation that has no effect on the protein whatsoever. Silent mutations are said to be neutral because they don't really change your ability to survive and reproduce. How does this happen? So if you change your DNA, how does that not affect the protein? Well, this can occur because the genetic code is redundant. You will recall in the genetic code that many codons actually code for the same amino acid. Here, you'll notice that all of these codons, CCU, CCC, CCA, and CCG, all code for the amino acid proline. So let's say, for example, that you have a gene, and a section of that gene, one codon in that gene, might read GGA. Okay? Well, this is going to cause an mRNA to read CCU. So CCU is the codon that codes for proline. Now let's give this section of the gene a substitution. Let's substitute that adenine for, let's say, a thymine. So that DNA is going to create the RNA codon CCA. Well, if you notice, CCA codes for the same amino acid, proline. So here, this substitution, the A for the T, in that spot on the codon, actually doesn't affect the amino acid sequence at all. Where there was a proline before, there is still a proline. Another type of substitution mutation that can occur is a missense mutation. A missense mutation, another possible outcome, occurs when the gene product or the protein is altered so that one amino acid changes in the protein. So let's give you an example of a missense mutation where one amino acid changes. Okay, so imagine we have this other gene, okay, and one codon in that other gene might read TCA. So this codon will give rise to the mRNA AGU. Well, as you can see from the genetic code, AGU is the codon that codes for serine. So let's do a substitution here, and let's swap out that A such that the codon now reads TCC. So here we've substituted an A for a C. Note the mutation is a substitution. This will give rise to the mRNA AGG. You will note that that codon is the codon for arginine. So this substitution, an A to a C, has caused the amino acid sequence to change by exactly one amino acid, a serine for an arginine. Again, that's called a missense mutation. So is that going to be catastrophic for the cell? Well, maybe, but here's an example. Let's go back to lactase, okay? Lactase normally has this shape right here. Let's imagine for a second that that's the normal lactase. Maybe this mutation only caused a slight little change in the structure of lactase. If that's true, then lactase will certainly still be able to bind with the lactose, and it will still be able to break it down, and you really won't be affected. You can still drink milk, you can eat cheese, and really enjoy those dairy products without having an upset tummy. So it's possible that a missense mutation doesn't really affect the protein at all. So let's talk about our final sort of substitution mutations, and these are the nonsense mutations. This is another possible outcome. A nonsense mutation occurs when a point mutation changes the gene product by altering a codon so that it becomes a stop codon. You'll recall that stop is not an amino acid. It's an instruction to the ribosome to stop making the protein. It's done. So this time, I want you to imagine a situation in which we have a gene with a codon that reads A T A. Okay? So there's our codon in our DNA. Now, if we transcribe that into mRNA, we get UAU. And UAU codes for the amino acid TYR, tyrosine. Now, I want you to imagine that we're going to do a substitution here, substituting that third base. So instead of ATA, we've got ATT. Note that we've substituted that A for a T. So here we have a substitution mutation that's going to affect the codon, such that that codon is now going to read UAA. You'll remember that that codon codes for a stop. Now, is this going to affect the protein? Well, let's go back and look at our protein. You'll recall that our protein here is made of a bunch of these amino acids, right? So it really depends on where this nonsense mutation occurs. If it happens towards the end of the protein, chances of that one amino acid really affecting the protein are really small. But if this mutation happens early on, say right here, then that protein is only going to be made of 3 amino acids. Now, surely that protein's not going to have the same shape as it would have before the mutation, so it's probably not going to function very well at all. So that's our first type of mutation, the substitutions. And substitutions, again, can give rise to silent mutations, to missense mutations, and to nonsense mutations. So our last two types of mutations are the insertions and deletions. Those are not very fancy names, and they're really straightforward. So an insertion mutation occurs when a base is inserted into a gene. Okay? So instead of having A in the gene, you could imagine that a T might be inserted there, such that that gene now reads A, T, A. So what impact does this have on the protein? Well, you'd be surprised. You remember that the genetic code is read in 3-letter words, or 3 base codons. This is a lot like the sentence, the fat cat ate the rat.
Daddy,
Yeah, Sam.
can you give me some minutes to eat and can you turn on?
Yeah, give me 5 minutes, okay? I'll be right in. So we've got this sentence here. Now I want you to imagine that we're going to insert a letter. I don't know, let's say my favorite letter, A. So that sequence of codons is now going to read the alpha. There's the A we inserted. Ka, tat, eth, era, t. Now, what kind of sense does that make? Of course, it doesn't make any sense at all. So insertions are really jacked up mutations because what they do is they totally change the amino acid sequence from the point of the insertion all the way down the line. This is called a frame shift because it shifts the reading frame of the gene. Deletion mutations work much the same way. Deletion mutation is when a base is deleted. Okay, so let's look at our sentence again. We have the fat cat ate the rat. Now this time we're going to delete a base. So imagine this F here is deleted. So instead of the fat cat ate the rat, what we'll have is a sentence that reads, hold on, Sam, give me 5 more minutes, all right? Yes, I'm almost done. Thank you for your patience, class. Sam, 1 minute. I'm very busy. Thank you. What you're going to end up with is a sentence that reads something like, the act atta tet her rat. Again, what kind of sense does that make? It doesn't make any sense. You will notice that at the point of the deletion and all the way down the line, we have another frame shift. Now, if you think that's not a big deal, I ask you to again look at our protein. If you were to change, starting at, say, this point right here, all the way down, if you were to change all those amino acids, that protein's probably not going to work because it's not going to have the same shape as it would have. And again, a protein's function is all about their shape. I invite you to please watch the videos on YouTube right there and there. So, I hope you can now identify and describe the 3 types of mutations: substitutions, insertions, and deletions. And now I know that you can determine how a mutation will affect the protein.